Welcome to Introduction to Oracle 9i, SQL and PL/SQL, Oracle Certification Course 1Z0007. In this Oracle Certification course, we will be covering SQL, or Structured Query Language, and PL/SQL, Programming Language for SQL. Other Oracle Certification courses will cover areas such as General Database Administration, Backup and Recovery, Tuning Oracle Databases, and Oracle Networking Software. My name is Gavin. I am your instructor. I have 15 years of Oracle Database Administration, Programming, Development, and Unix Administration experience. What you will learn on this course: you will learn all about SQL, Structured Query Language, and PL/SQL, Programming Language for SQL. You will also be introduced to the Relational Database Model and learn to use some of the Oracle tools such as SQL+, SQL+ Worksheet, and Oracle Enterprise Manager. We will also delve briefly into the architecture of Oracle, thus you will learn how to create logical database objects, such as tables, indexes, etc. Prior knowledge requirements for this course: it would be useful to have some programming knowledge, some SQL knowledge, and some relational database modeling knowledge, although none of these skills are essential at this stage. We will be looking at a number of websites. These websites will specifically contain Oracle manuals, referential information, and other information about Oracle certification. What is Oracle software? Oracle software is primarily a relational database engine. Additionally, Oracle includes a large number of application kits such as human resources, financials, CRM, sales, amongst many others. Oracle also has a very capable application server, plus a large number of custom development kits and environments. Let's take a look at a number of useful websites. In the address box on my browser, I'm typing in http://www.oracle.com. and I hit return. There are two areas on the Oracle website that we're interested in at this stage. The first is the Services area and the Oracle University link. The second is the Downloads area. Firstly, let's click on the Oracle University link. This is the Oracle University webpage. You will find a large amount of information on this webpage about Oracle 9i certification. Now let's go and look at the Downloads section. Go back to your address bar and once again type in http://www.oracle.com. Now let's go to the Downloads section. Go across to the Downloads button at the top right and click on that link. Now we're at the Oracle Downloads page. Oracle will allow a 30-day temporary license on Oracle software. Bear in mind that this download is extremely large and is best downloaded using a DSL or cable internet connection. A modem will not do, unless you want to wait 3 days for it. The best option to download is Oracle 9i Personal Edition. It's simple, it works on Windows 98, and should work on Windows NT as well. The other point to note is that you can actually order a box set of CDs from Oracle. The second website we're interested in is commonly known as TechNet. Go to your address bar in your browser and type in http://technet, spelled TECHNET.oracle.com. TechNet contains reference manuals for anything you would need to know about Oracle. Primarily, For this course, we are interested in a small number of manuals, those to do with SQL, PL/SQL, and the SQL Plus and iSQL Plus tools. We are now at the TechNet website. I'm going to use the scroll bar to scroll down a little. I'm going to move my mouse across to the left of the screen and highlight the documentation link. I will then move my mouse over to the Oracle 9i database link and click that link. This is the Oracle 9i database documentation. The one I'm most interested in is this area. You can use an HTML version, hypertext markup language, or a PDF version. I prefer the HTML version. I'm going to click the HTML link. On the subsequent page, I'm going to click the List of Books link. This gives me a whole list of Oracle reference manuals. As you can see, there are many. The manuals we are most interested in for this certification course are as follows. Scroll down and we find the SQL reference manual. Let's click the contents. This manual will cover anything and everything about SQL. Now let's go back. So this is a useful manual. These three manuals on SQL Plus are also useful. Another manual which is useful is the PL/SQL User's Guide and Reference. What is Oracle software? Oracle is a database, a relational database. There are many other pieces to Oracle software, namely application software and an application server. There are many applications in existence, such as the first application which came out many years ago was the Oracle Financials application suite. There are now applications covering all sorts of subjects, anything you can imagine, CRM, customer relationship management, sales, human resources. There's a whole list of them. What is Oracle used for? From the perspective of SQL and PL/SQL, Oracle is used as a database engine to store data and manage the retrieval and update of that data. Who uses Oracle? Small companies, large corporations. There are thousands, if not tens of thousands, perhaps even hundreds of thousands of Oracle installations out there on a global scale. Who are the competitors? As seen in the pie chart on the left, competitors to Oracle Corporation are SQL Server from Microsoft, DB2 from IBM, and on a much smaller scale, relational databases such as Sybase and Infomix. There is a section for other databases. These other databases would be other relational databases such as Ingress or even Microsoft Access and any object databases. Why is Oracle so successful? As you can see from the pie chart on the left, Oracle claims 54% market share. This market share is capitalization. What this means is that this is the amount of money that has been spent on Oracle, or is currently being spent on Oracle. Oracle is so successful for a number of reasons. Firstly, Oracle is very diverse and very flexible. As far as database administration is concerned and the managing of databases, more or less anything can be done with an Oracle relational database within the scope of the database market. Secondly, Oracle has been very successful in creating applications What Oracle can actually deliver is an end-user application as opposed to just a database. What I mean by just a database is that a company would buy a database other than Oracle and would have to build the application software. This is not true in every case, but largely that is the case. Oracle has been successful by selling applications, end-user applications, in addition to the underlying database software. Thirdly, Oracle has been very successful at marketing. The history of databases. Databases have gone through a number of generational changes, right back from the mid-40s. Initially, database data, if you can call it a database, would have been stored in file systems. As you can see from the diagram, right back to 1945, any storage of data would have been stored in file systems. The file system implies a flat file, text file, binary file, something like that. Around about the mid-50s, somebody came up with an idea for a hierarchical database. A hierarchical database is a tree structure. In other words, you would have branch nodes and leaf nodes, where the branch nodes would determine where something is stored based on the value of that branch. Like a tree. Just imagine a tree upside down. That's what a hierarchical database is. In the mid-60s, the network database was invented. This was the next generation on from the hierarchical database. Around about the mid-70s, somebody came up with an idea called a relational database, based on mathematical set theory. We'll get into that at a later stage. The mid-80s saw the advent of the object database. An object database is somewhat different to a relational database. Well, in fact, it's very different because it stores everything based on a globally identifiable object number or address, whereas a relational database stores things based on groupings of how they relate to each other. Let's not get into that too much at this stage. Object relational databases were really invented around the late 90s to counteract the potential competition from object databases. What an object relational database effectively is a combination of a relational and object methodology where certain object aspects are included within a relational database, thus an object relational database. The history of relational databases. As you can see from the diagram, Dr. Edgar F. Codd wrote a number of papers in the late 60s and early 70s describing what a relational database is and how it would work. He created the first three normal forms. Once again, that's something, normalization, we will get into at a later stage. But that was the genesis of the relational database. Fourth and fifth normal forms came along later as an addition to the original relational database theory. IBM really produced the first relational database called System R. System R effectively allowed the creation of SQL or SQL or the structured query language. IBM currently markets a relational database called DB2. They have 11% of the market. Going back to the initial creation of relational databases, two scientists at the University of California, Berkeley developed a database which they called Ingress. As you can see from the diagram, the acronym comes from Interactive Graphics and Retrieval System. They created the first commercial relational database. Sometime after that, a company called Ingress Corporation was created to market and sell the Ingress relational database. This area is generally very much open to debate among DBAs. However, I tend to have a slant towards Ingress, and I used to be an Ingress DBA. All relational databases stem either from Ingress Corporation or from people who originally worked on the Ingress relational database, such as on the right you can see Infomix and Sybase. Some of the people from Ingress Corporation ultimately ended up working for Oracle Corporation, and they obviously brought their knowledge into the creation of Oracle and the evolution of the Oracle database in the same way that that knowledge was taken to Infomix and Sybase. Again, Oracle's 54% market share goes back to the fact that Oracle, firstly, they've been much more successful at marketing. The result of this is that they've made a lot more money and they spent a lot more money on development. Even though the Ingress database and the Ingress people initially set out to create the best database possible, they lost market share due to the fact that they didn't necessarily keep up technically, or not necessarily technically, perhaps even in terms of providing customers with what they need. Oracle gave their customers end-user, usable, out-of-the-box applications, as you can see on the right, plus they gave them the development environments for client-server development environments, internet development environments, and obviously, as you can see by the cloud down the bottom of the diagram, a cloud is often used diagrammatically to represent the internet. The ultimate in Oracle development is the Oracle 8i and Oracle 9i internet databases. The history of Oracle and the Oracle Relational Database. The first version of the Oracle Corporation was a company called RSI. In 1979, they released the first version of Oracle, including use of SQL, structured query language. This version was actually version 2 of Oracle, but that's besides the point. In the early 80s, Oracle came up with a few new ideas, which increased marketability, usefulness. Let's try not to confuse the use of the word marketability. By marketability, I'm implying that the product is useful to a larger number of people, rather than actually just selling it to make loads of money, which is obviously the objective as well. In the early 80s, RSI decided to rename itself to Oracle Corporation. This was something to do with confusion between the name of their company and another. One of the really important things they did in the early 80s was cross-platform compatibility. This means that Oracle could be used as a database on multiple platforms such as VAX, VMS, Unix, etc. They also created portable toolsets. In other words, the tools and the bits and pieces that were used with Oracle to manage the database, access data, etc. could be used across different platforms. It's difficult to understand that these days, since that sort of thing is all taken for granted, but in those days it was a big leap. In the mid-80s, the client-server architecture environment came along. Oracle catered for it. They also created fourth-generation languages, which is what 4GL means here. In the late 80s, Oracle really came to fruition by creating financial applications. Financial applications was the start of Oracle selling customers, or providing to customers the ability to not have to go and develop their own software and spend an absolute fortune creating custom-built applications. By providing customers with a financial application, customers are given a more or less out-of-the-box, not necessarily shrink back, but out-of-the-box, very close to being ready application usable. They don't have to create their own departments to develop their own software. Also in the late 80s, Oracle 6 was introduced and SQL was first introduced. In the early 90s, Oracle 7 was introduced. Aspects of Oracle 7 which were introduced in the early 90s included referential integrity, very important for relational databases, cost-based statistics and optimization, very important for tuning and speed. Clustering. Clustering implies placing a database on many machines at once. This implies scalability. In other words, you can make your databases much bigger and able to handle a much larger load. In the mid-90s, the Oracle 8 database came along. Oracle 8 was effectively the object relational database. Also, the application server was introduced, and the thin client, which is getting to the point where storage is not required on a client machine. Client machines become cheaper. It's gradually moving towards use of internet browsers, the internet. Much lower cost in terms of having to buy lots and lots of very high-powered client machines. The PC sits on your desk. In the late 90s, the Oracle 8i Intranet database was introduced. The Intranet database is effectively allows for a large number of users to connect. It's sharing and pooling of resources. Also in the late 90s, Oracle introduced what I call the database kernel embedded Java virtual machine. This embedded JVM allows you to create stored procedures or procedural code in the database itself written in Java. It may be apparent to some people that this could be slow. Yes, it could be, but it's also very powerful in terms of coding power. There is, however, an addition to the database kernel embedded JVM where Java code can actually be compiled into binary. It's called the Java Accelerator, and it can make that Java executable code extremely fast. In other words, it does no longer execute inside the Java virtual machine. It can be made to execute as a piece of compiled binary code. Y2K+, the year 2000 and beyond. Oracle 9i was introduced. There's a lot of middle tier development around and after the year 2000. Oracle 9i is the next generation on top of the Oracle 8i Internet database. About this course, Oracle Certification 1Z0007. In other words, what are we going to cover in this course? I have an initial list of items, a general list of items. These are the relational database model, basic Oracle architecture and the physical database, the tools used by Oracle SQL and PLSQL, how to maintain the logical database. The logical database is different to the physical database in that the logical database is the layer that overlays or lies on top of the physical database. Retrieving data from the database, selecting data using the select statement, getting information from the database. Changing data, adding new data, changing data that's already there, or deleting data in the database. The logical database, database objects and security. What are logical database objects? As already stated, logical database objects are the objects in the database overlaying the physical database, the physical file structure. Logical database objects are the things or objects in the database which make up the relational database. These are tables, constraints, indexes, sequences, synonyms, and views. We will go into what all these are at a later stage. Users and security. This implies you can create multiple users in an Oracle database, and you can apply certain security restrictions and or access permissions to those users. How do we retrieve data from Oracle? We retrieve data from Oracle using the SQL select statement. The select statement is part of the structured query language. We will also look into single row functions. There are many Oracle written functions which can be applied to each row in a select statement. For instance, calculations on columns such as changing data types or formatting dates into day, month, year as opposed to month, day, year. There are a multitude of single row functions. We'll go into those. Select statements are filtered using the where clause. The select statement retrieves the data, the where clause applies a filter. By filtering, we mean we do not retrieve everything selected by the select statement, but we take some of it out and we only return a small percentage. Sorting the select statement is executed using the order by clause. In other words, whatever we retrieve from the database using the select statement can be reordered or resorted using the order by clause. We will look into joining multiple tables. By joining multiple tables, what we do is we select data from more than one table at the same time and stick them together according to certain parameters. We will also look at summarizing data using the group by clause. The group by clause is a method of taking multiple records and summarizing sets of those groups into groups. For instance, you want to take a sum of an amount across a whole table. You would use the group by clause to add it together into a single row return. Group by result sets can be filtered using the Hammond clause. There are also OLAP extensions to the group by clause. We will discuss those later. Subqueries. Subqueries are extremely complex. This is a very interesting area where you can actually create a select statement or a query within another query. The commands that Oracle uses to change data in the database are called DML commands, data manipulation language commands. These commands are insert, update, delete, and merge. Note that I have left truncate out. Truncate is not actually a DML command, although it has the same effect as the delete command. We'll go into that further later on. What are DML and DDL? DML stands for Data Manipulation Language. The DML commands are used to change data in the database. DDL actually means Data Definition Language. The Data Definition Language is used to change objects in the database. In other words, change a table, add a column, remove a column, change a data type. The DDL commands are used to change the logical structure of the database, the metadata, the data about the data. The DML commands are used to change the data itself in those objects. The column values, the rows, the customers rather than the definition of the customer. We're also going to look fairly seriously at the programming language for SQL, the programming control language that can be used to create stored procedures in Oracle, amongst other things.